So now we're going to talk a little bit about the results and discussion section of your paper. So these are the sections that are really critical to the paper. It's where you finally get to show your results and you get to have your say about what you think about them. So the results section, first of all, this is the main event. This is the hero. A lot of the times when, as scientists, we're reading other papers, we might turn straight to the results section because a lot of the introduction we might be familiar with, or the background behind why someone did a particular study may or may not be relevant to us. What we really want to know is what was found, and we can see that in the results section. The results section should contain the results, all the results, and nothing but the results. So what that means is you shouldn't be interpreting, speculating, your opinions about the results. All of those things belong in the discussion section. In the results, this is really just about stating what you observed and presenting those results. So you might think, well, that's going to make it a little bit dull, or there's not going to be a lot of information there. But that's not actually true. It's really a beautiful thing when someone can present scientific results, and it's so useful and informative to other people to be part of this scientific process where someone has recorded a result and then you get to absorb that result and build on it, that there is beauty in that. So don't feel like you need to pad out the results by putting interpretations or other embellishments on it. Just state the results. That's really all that it needs to be. So a lot of the times we wrestle with what results to put in. The best way to guide you with that is that it's all about the hypothesis. Whatever that study was about, that is the backbone of your paper. So if you've written a good hypothesis where you know very clearly exactly what the study is, then you already know what your first figure is going to look like. That, if possible, you want to put that first. That is your main argument. That is your main finding from this body of work that you've done. So sometimes you might have to experiment a little bit with the order, but jot down all the results that you have, because while you'll have your main result, that'll be the key, it's likely that you'll have other results as well. So pop those down if you've got multiple things that you want to present, and play around with them. You might change the order several times before you decide. You also might have different ideas on how you present those results. So some data works better as a graph, sometimes it works better as a table, and often you only figure this out by experimenting. So definitely don't be shy to mix it up, to experiment with different ways of presenting data and also different orders, and until you settle on something that makes sense to you. Okay, so we're going to use an example. This is a study that I conducted in one of my medical genetics classes, and the hypothesis was that students exposed to an additional introductory module on bioinformatics incorporating basic molecular understanding and an online instant feedback tool. So for those of you who recognize this, if you've done our bioinformatics class, you may have actually done this introductory module. And this experiment was about when we tested that module. So the hypothesis was that students exposed to that module will report higher student confidence extracting information from bioinformatics databases than students who didn't get the tutorial. And secondly, it would be more likely to report that they would consider working with bioinformatics as a career. Now that second one may surprise you, but we have seen in other studies that we've done and in other topics that where we can increase the student's confidence level, they're more likely to choose that thing as a career. So that is a deciding factor for students. So what we thought in this study is that this additional module would not only help students understand and make them feel more confident, but that it might actually influence their career choice. So what did we find? Our main finding was that student confidence indeed was increased. So first of all, it was increased after the bioinformatics activity compared to before. This makes sense because while doing the bioinformatics activity, hopefully students have learned something, so their confidence was up. That's great. Secondly, exposure to that introductory tutorial further increased the students' confidence at the end. So our tutorial did what we expected it to do. It did increase students' confidence even more than if you didn't have that introductory tutorial. And because that's really key to the hypothesis, those things we're putting right up front. So the first figure and the first table contains the data about student confidence because that's the main primary subject of the hypothesis. A second part of the hypothesis was about career perception, and our finding was, despite that improved confidence, student perception of bioinformatics as a career did not improve. So despite our best efforts, we just can't make students want to be bioinformaticians. Okay, that's also part of our hypothesis. So also in that table 1, this is the data that comes right up front for this particular study. We also have some other findings, right? Because it wasn't, when we construct a study, we don't tend to just look at the hypothesis. We look at those other things that we can measure as well. So we saw the greatest gains in confidence were seen in students who had not previously encountered bioinformatics. So we separated the students based on those who had done bioinformatics before and hadn't done bioinformatics before. And so confidence at the start was different between those groups, but after our tutorial, it ended up being the same. So basically, we leveled the playing field for people who, whether they had done it or not done it before. And finally, the last thing we asked of students was what did they find most helpful? So they, the most helpful thing that students rated were in-class tutors, that helping them, guiding them through it. But they also did consider that introductory tutorial and the auto grading tool to be helpful. Okay, so that's a summary of the main results that we found in this study and the order that we would put them into. There are a few conventions when it comes to figures and tables. If you're not sure, because there's lots of different types of figures and tables, similar to what you might do with a methods, just go looking at papers and find what other people are doing. That's a really good way to understand the conventions of the field. But there are a couple of rules. So a figure with its legend, that should stand alone. It should tell the story of that piece of data. You shouldn't really, as much as possible, you should avoid that the person reading it has to go flick back and forth through the text to find out what that figure's about. A good figure and figure legend, a reader should be able to look at it and have an idea of what's happened. So you might use some abbreviations. That's okay. If there are abbreviations that are used throughout the paper and it's a really key thing that you're discussing. But if it's something new that's being introduced for that figure, then you may want to define it there right with the figure. Figure legends always go below a figure. Table headings always go above a table. These are just conventions. And as I mentioned before, if you're not sure how to present a particular kind of data, find some papers. That's the best way. Okay, that's the results in a nutshell. Now we're going to move on to the discussion. And this is really cool. So the discussion is where you get to have your say. So while the results is quite restrained and limited to your objective observations, the discussion is really where you get to interpret, to speculate, to say what you think it means, to say where you think it's headed next. All those things that you're really dying to say, you can discuss them in discussion. There are some a couple of hints that I want to give you. So this was a tip that came from that scientific writing book that I've recommended a couple of times. Discuss your results in the context of other studies and do it in that order. So as we're writing a discussion, it can sort of jump around a bit because you have to talk about your results and you have to talk about previous results and you're going back and forth between those and, well, that person found that, but we found that. And okay. This is a framework that will make your discussion a lot neater. So a bad example is that Brown, Bloggs and Davies found that A increases B, but that was nothing at all like our results, which were that A and B are independent. And your conclusion from that might be their methods were rubbish, which is why we think our results make more sense. As a sentence, it's fine, but it risks that you're going to be jumping back and forth between past and present, and it can get quite confusing. And more to the point, we've talked a little bit about the start of a sentence being the position of power. Here you're giving Brown, Bloggs and Davies the position of power. It's much better if you can put your results first and keep the reader thinking about your results and thinking that your result really is the primary important thing that matters. So, to restructure that sentence as a good example, we found that A and B are independent. This result was in contrast to previous studies by Brown, Bloggs and Davies, who found that A increases B. Their methods were rubbish, which is why we think our results make more sense. This example flows better because you start off by talking about how A and B are independent, your result. Then you talk about Brown, Bloggs and Davies, and you dismiss that by, I presume you have a better critique of their methods than just was rubbish, but and then you turn back again in the position of power. You finish off that paragraph with our results make more sense. This is persuasive writing. This is going to get your message into the heads of your readers, which is ultimately should be your goal with writing, with all writing, but especially with scientific writing. So what do we put in the results, in the discussion section? Very similar to our results. It's all about the hypothesis. So make sure that main argument, that main finding, the crux of your paper, put that right up front. That should be your first thing. Then you're going to follow that by supplementary arguments, and you'll also talk about limitations. When it comes to limitations, there are a couple of different types of limitations that I want to talk about. One is the limitations of this study itself. And by that, I really mean if the way you've done things will mean you can only interpret it so far. Let's say, for example, you're working with an animal model. You can't interpret necessarily that this is going to translate to humans. It's a limitation. It's still informative, but that's a limitation of your study. The different type of limitation is with this type of work, there may be general limitations to the extent that you could use it. And this might be, let's say you're using a technique, but then if that technique you wanted to deploy as being a population-wide screening tool, but it was going to be far too expensive, then that would be a limitation of what you're working with, a limitation on how it could be applied. So those are the kinds of limitations I want you to think about. Limitations of your study, and then also limitations of the practical application of what it is that you're doing. So there's quite a few points that you might have to make in your discussion. Figuring out the order, it's much like the results section. Jot down all your arguments, put them into dot points, and then move them around until you like the order of them, and that makes sense. You can start with dot points and then make them for paragraphs later, but you'll get a much neater and easier to read discussion if you do this than if you just start writing entire sentences and write your discussion start to finish. So consider each argument in the context of the literature. Like I said in the previous example, discuss your results first, then put it in context. And for every argument, you should be able to do this. You should look at this was our result, and then in the context of what has been done before. In this process, you might be going back and forward through the literature. So presumably before you did the study, you will have done a literature search. But based on your findings, you might now have to go back and read more. There might be unexpected things that came up, and now you have to dig a little deeper to see if that's been found before. So as you're searching the literature, and then you're coming back to your results, and then you're searching the literature again, you'll go a little bit back and forward, but this is how we write a discussion. And then that's you as an author doing the work so that the reader can properly interpret and make sense of your results. Okay, so back to our bioinformatics example. Let's look at how the results section will compare to your discussion section. So our results were that student confidence was increased after the activity compared with before the activity, and that exposure to the introductory tutorial increased student confidence even more. Okay? So in the results, that's all we will say. We will say that we observed increases, and we leave it at that. In the discussion, we'll now talk about what that means. So, the discussion, the extra module increased confidence after the tutorial. This is a good thing because bioinformatics skills are essential for graduates of biomedical science subjects. Students lack confidence in their ability. Now we're interpreting, okay? So you need to state your result and then put it in the context. The next result, confidence before the tutorial was higher in 2014 and 2013. So this is a lesser argument, so it's next. It doesn't come first. Our main argument comes first. But here's a discussion that a point that we have to discuss in a negative light. We wouldn't have expected confidence before the tutorial to be higher one year than the next. That was an unexpected finding, so we now have to deal with that. The discussion is the place that we do that. Here, this may have arisen due to a flaw in the study design. Students were asked to retrospectively affect on their ability. Now you will give your reasons, now you give your limitations. So this is what a discussion should look like, each paragraph being a different point of what you need to bring up and what you found in your results, and then discussed in context, and with your main finding being up front, and then limitations and lesser findings coming next. It'll mostly come in the same order that you put things in the results, and it might take some experimentation to figure out what a good order is. So that's all I have to say about results and discussion. So the main things to remember are that the results are all about stating what you observed. You want to put in the results, all the results, and nothing but the results. And then the discussion is your place where you can now speculate, you can interpret, you can talk about the limitations, and you can talk about the implications of your findings. So hopefully that'll help you with those two sections, and good luck writing.